Why, hello everyone. Thanks for joining us today. This is Dean Woodbeck from Incommon, and you are joining IAM Online. IAM Online is brought to you by both Incommon and the EDUCAUSE Higher Education Information Security Council. I want to point out one thing that we'll be taking questions via the chat, and you can look at the bottom of your screen and there's a little chat bubble. You have to click that in order to see the chat. And then once you're in the chat, you'll see it says to, and I believe the default is all panelists. So if you click on that little down arrow, you'll see one that says all panelists and attendees. You should choose that when you're placing your question in the chat so that everybody can see it, and then everybody will be able to see our answers. So without further ado, you can see the title on the screen for the topic today, and the presenters are Eric Coleman and Keith Wessel, both from the University of Illinois at Urbana-Champaign. And Eric is up first, so take it away, Eric.
Yes, thanks, Dean. Hello. So I wanted to do a little bit of a redux. If you were at the Global Summit a couple conferences ago, we did a presentation very similar to this. This is kind of a rebooted version. So I wanted to start off by kind of taking our trip down how we got here. Basically, we had two big events that moved us forward into adopting public cloud. The first one was a cloud-first strategy that was kicked off by our former CIO. As typical for many organizations, we had a kind of cost rationalization of our server infrastructure, which pushed us toward adopting public cloud in an attempt to try to cut costs. Amazon Web Services was our very first engagement. That was deployed about 3.5 years ago, I think, and we've since recently added Azure, and we'll also soon be adding Google Cloud Platform as offerings as part of our institution as well. So the central development team in our technology services, which is our central IT arm, devised our first DevOps workflow, which was scoped to include just the in-house managed central applications. And this process basically favored the building of cloud resources using Amazon's Elastic Compute Cloud, or EC2, as you'll see, and as well as Amazon's Elastic Container Service, or ECS. And Fargate is actually just Amazon's hosted Docker container cluster. The second big event was in 2017, we joined Incommon's Collaboration Success Program as a participant school. The big carrot for us was their development of the Trusted Access Platform, which is basically a set of standards and pre-built container images built around a lot of the popular Incommon higher ed software, mainly Grouper, Shibboleth, as well as CoManage and Midpoint. So we set out to see if we could combine some of these pre-built images as well as with our drive for this cloud adoption and develop some proposals. So Grouper was kind of the easy part because it was brand new to us. So we did a from scratch greenfield installation. So that seemed like to be low-hanging fruit. And then Shibboleth, being the only other one that we really have in production already, seemed like a logical choice because it was pre-existing and that we could maybe migrate that into a hybrid mode where we would sort of at least establish both on-premise and cloud presence for our Shibboleth IDP. So I'm going to go over some of our AWS experiences, many of which apply to both Grouper and Shibboleth, but then I'll cover some Grouper specifics, and then I'll hand it off to Keith Wessel that'll talk about some of the Shibboleth specifics. Another thing that may be worth mentioning right now is that the that Collaboration Success Program is about to kick off another round this fall. So watch for announcements. Actually, I think the announcement's already out, but coming up this fall, there's going to be some kickoffs. If your school is perhaps interested in joining this, we certainly highly recommend it. We kind of come as an alumni with a good experience from the program. So here's a diagram that in one slide shows our DevOps process. It's still an emerging process, kind of a work in progress. So we're not quite to the full CI/CD pipeline kind of thing, but basically we're supporting a continuous delivery model where basically all of our the image building scripts and whatnot are all infrastructure as code in GitHub, basically 2 repos. And so if we want to make changes to our image, we can do a git push to our GitHub repository, and that will cause drone, which is our continuous delivery mechanism, to automatically detect that new push and execute the Docker builds and push the image up to the Amazon ECR, which stands for Elastic Container Registry. So we'll have an image ready for deployment in the ECR. On the other fork there, you'll have, we basically have to build the infrastructure out as cloud resources, and that's where we use Terraform to build essentially the resources and then push the container tasks, which are nothing more than JSON files, up to an Amazon S3 bucket. And with those 2 in place, then we can actually deploy the application in Fargate as a running container. And then the rest of the process is a little bit manual. So basically with some quality assurance and testing, when we can are satisfactory with the changes, then we can move that to our production account and deploy those as a production instance of the container. And then the cycle completes, and then any other changes, feature requests, patching, or upgrades are basically looped back as a change in GitHub, and then the process repeats itself. So the one part is, besides the drone for the continuous delivery, is setting up the AWS infrastructure, and that's where we've chosen Terraform to declare our infrastructure as code. It's a platform agnostic declarative language. If you're interested, the website's terraform.io. And basically that's where we define our infrastructure elements, which include networking subnets, security groups, the load balancers, and then various tasks and properties of the containers, including the mappings from the AWS parameters into environment variables using AWS's SSM, which stands for Simple Systems Manager, which has a parameter store, which we'll see that in a couple slides here. And Terraform has an advantage better than, say, AWS CloudFormation, because Terraform is platform agnostic, so we can adopt the same language and standard process to our Azure applications. Now here's a screenshot of Drone. Drone is another open source tool designed to be a continuous delivery platform. And you'll see in this example, the build that we've got is Tech Services Illinois is our main org, and then Authman happens to be the name for Authorization Manager, which is the service branding for our grouper installation. This interface authenticates using GitHub, and we can see on the left various pipelines, which are basically showing their status icons as to whether or not they completed successfully or failed. And then you can see in the green box the commit message, where this particular one updated to, and then I have an inclusion of the tier grouper Docker image name, just to show me a reference that I had recently upgraded to that, and that this is build attempt number 156 since the dawn of time. And so if I were to make a change to this, the git push would be then triggering Drone, and I would see in real time on this web page the status of it, and would increment the build number and push the image out to that Amazon ECR. I could also use this interface to roll back to a previous Docker image if I were to find something wrong. Oops, and that would allow it to basically re-push the ECR, the older version of the image, up to the ECR, because AWS Fargate is always going to use the image tagged as latest. So something to keep in mind there. Now that's about all there is with the basic DevOps infrastructure. So let me dive into a little bit more of the specifics on Grouper. So here's a brief look at our Grouper architecture. We deployed in production in March, and we've been getting a slow but steady increase in its use for authorization policies. We chose the serverless architecture using the ECS Fargate because that was the quickest path with the pre-built Incommon technology trusted access platform containers. So The clients that you can see there, we've got the 3 nodes, the daemon, the UI, and the web service. And the 2 that need essentially a web endpoint are balanced behind an application load balancer, which is technically hosted under the Amazon's EC2 platform. And then all 3 of those nodes then have a backend connection to an Amazon RDS, or relational database service, that is a MariaDB database that holds the standard grouper application database. Then way on the back end, we've got a Cloud9 instance, which is basically a console in the cloud. It's AWS's development environment, so to speak, that has an HTTP interface, but it comes with all sorts of nifty tools like Python and Docker and everything you can imagine you'd need. So we use that to do our management of the GitHub repo, as well as to be able to launch Grouper Shell if we need to go in and maintain Grouper as an admin. And it's all cloud-based, so we don't have to worry about connections or network paths and things like that. So taking the Trusted Access Platform image and layering on top of that was pretty simple. In fact, we don't really have a lot of customizations. The obvious one would be our configuration files. All our grouper property files are changed to customize to point to our external dependencies. We actually rip out the HTTPS components because the application load balancer is what's terminating the SSL. And so everything behind the ALB is talking just straight HTTP. And then we also had to import the Incommon intermediate certificates so that Grouper could talk to our Active Directory LDAP in a proper secure way. And we also simplified that all of the Grouper nodes are actually sharing the same source image. So we just have one image in the ECR, and then we have an entry point script that determines the type of node or role that Grouper is going to execute as. Made it much easier to maintain. And any sort of specific customizations we need to do for one or the other could be handled by that entry point script. So external dependencies are pretty simple too. We basically use our on-premise or on-campus Active Directory as our subject source for the people for Grouper, as well as the provisioning target for some groups. But we do have domain controllers available in AWS in a separate VPC that is peered with the VPC that's hosting Grouper. So we have a very convenient cloud-to-cloud interface there, which can fail over to the on-premise DCs if there were to be a problem with that. Shibboleth, of course, is our authentication provider. And then as we saw in the diagram, that we have the MariaDB as our backend database. Oh, and I should also add that the Shibboleth SP is already burned into Grouper as part of the what's provided by the Trusted Access Platform. So some of the gotchas that are not unique to Grouper, but would also need to be considered for Shibboleth too. I'll touch on the first few in the next couple of slides: the storage of the secrets, environment variables, and logging. The backend networking, it's really just the only real gotcha there is that you just have to understand that the software-defined networking in Amazon is a bit of a learning curve, and we had to understand the differences between public and private subnets. And in the diagram, you saw everything connects to that backend RDS database, which is technically on a public subnet. So therefore, we needed to make sure we use proper network security groups to make sure that our connections to the database were scoped and limited to only the resources that needed to access it. Container sizing was another hurdle, and still kind of ongoing, basically trying to, because we're running I guess you could call it an older style Java application that's standalone, trying to set the heap size and the initial container memory sizes as small as possible while still providing enough of the resources to maintain the proper performance that would be expected and be able to sustain the operations of the application. It's just kind of an ongoing cycle there. We've not had too many problems yet. We're at about a 4 gigabyte container size at the moment, but again, our implementation is still not super widely used. It's still kind of early in the stages, so we're trying to figure out ways to monitor and mitigate as that use increases. Another thing that I didn't really cover is that because we have the ALB on the front end, we have the ability to then add additional nodes too in order to add additional resources to be able to handle the load as we go as well. So that's something definitely on our to-do list in the future.
And Eric, I'm going to step in for just a second because
Yeah.
Nick Roy asked if there was a reason that the RDS has to be on a public interface.
Our DevOps guys gave us a reason that that was the way it was going to be, and I'm trying to remember off the top of my head if why that was. It had something to do with the way that the RDS is deployed with the Terraform code, and I don't remember if it was a limitation of the Terraform module or if it was just a limitation generally. I'll follow up with you, Nick, on that. I've escapes my mind exactly what the rationale was that, but we were told that was going to be so.
And Nick's other question about is the Shibboleth SP's metadata consumption causing a lot of extra memory consumption? I believe you're only importing our local Illinois Federation's metadata and not the Incommon metadata. Is that correct?
Yeah, that is correct. For the Shib SP, we just have the our iTrust Federation data, which is minimal. I don't think so, although that's certainly worth maybe looking into. I think the most of our CPU memory utilization ends up getting consumed by, you know, like large searches and large group operations and that sort of thing. So I don't think I can blame Shib for any of that yet. So.
Groovy, carry on.
All right, thanks. So diving into the secrets a little bit, I'm sure we've all got servers out there that have got passwords configured somewhere, stored on disk securely, and that's great. But when we've got infrastructure code that's going into GitHub, you know, we've got to get the configuration in there. So it's a really bad idea to have the passwords hard coded in there. One idea would be to maybe just store them in a secure Amazon S3 storage bucket. However, an even better idea is to use something called Amazon's SSM parameter store. And we'll take a little bit deeper look at that here in a second. But you can also maybe use alternate forms. The parameter store just happened to be a way we chose to do it. But basically, you could actually have the secret stored in your drone as well. Your .drone.yaml file could potentially burn in the environment variables directly into the Docker images when they're built as well. So there's certainly more than one way to do that. But we chose the AWS SSM parameter store. It just seemed to be the most holistic way of kind of documenting those parameters as well, and we could incorporate that into our Terraform code as well. So taking a look at that here, we can see in the console that we've basically created a canonical path for our parameters here, in this case service authman LDAP bind password. And in the console, you know, I don't have the value showing there, so that's kind of nice. But basically in my JSON, in my Terraform code here, I've got a secrets block where I've got the value from referencing that parameter store. And then the name then associates it with the environment variable. And so then the environment variable then can be mapped into our elconfig class parameter in my grouper loader.properties, so that I can securely pass the password into grouper without ever in any of the chain of software have any password recorded. Now another consideration is logging. Again, the age-old problem, you know, your application logs are stored in just flat files on disk. Well, the disks in these containers is virtual storage that's ephemeral. You know, these containers live and die frequently, so that's going to disappear. So the only way to really recover from that is to get these logs immediately out of the container. Now the good news is that the Trusted Access Platform images have already been configured with log redirection to the console, so that anytime a log is recorded, then Docker is recording that as part of the standard out. So we've kind of devised a simple workflow here where when the app logs are piped out to standard out, because we're in the AWS Fargate infrastructure, those logs automatically get recorded as CloudWatch events. Amazon CloudWatch is their logging infrastructure. Further, we built a Lambda function, which is essentially a serverless block of code that executes on a trigger, and that trigger is anytime there's a new CloudWatch event recorded, and it processes and forwards those events over to Splunk by an HTTP event collector, in which Splunk can then ingest and index all of that log data. So it works quite nicely to the point that we basically have one generic Lambda function that handles all of our CloudWatch for all of our applications, and then each individual service and index has its own event collector to ingest, because then you can customize the log formatting and whatnot for Splunk to be able to index the data more specifically. And that's pretty much kind of the gist of everything we've done so far with Grouper. I'm gonna from here hand it off to Keith and let him talk a little bit more about Shibboleth.
Thank you, Eric. And since Eric was such a rock star and stuck within the time that we carved out for his part, I'm going to pause here for a moment and just see if anyone has additional questions to type into that Zoom chat. We did get a question from Lynn just a few minutes ago, Eric, about our team size and what experience we've had with going into this with Git and Docker and some of these other technologies. Do you want to?
Oh, sure.
Do you want to answer that one?
Yeah,
I wonder too, Eric, if you could maybe including in that maybe how what prompted you to get started on this project to begin with?
Well, I guess as far as the project itself, I mean, I think we had already had kind of rumblings internally to deploy Grouper to kind of augment our existing AD infrastructure, because AD was pretty much the pioneer Wild West as far as authorization management went. Everybody created groups and nobody took anybody out of groups, and so there was kind of a difficulty in managing it. So Grouper was kind of already in our minds as a way to kind of temper that. And so the combination of that with the combination of our cloud first initiative, and then the opportunity to be in the campus success program is kind of what the catalyst was for us to really kick this off and kind of go full speed, so to speak, on getting this deployed. Does that maybe answer the question as far as where we're going, why we started this? And I guess to answer the team size, you know, our IAM team and our development teams are two separate groups, so we only have what 5-6 people on our IAM team, and but our development team is really the ones that drove the DevOps portion of this, the Git use and the Docker and all of that, and they sort of were the pioneers with the development of that, and they only had a team of what, I guess 2 core people and then some additional part-time people.
Maybe 3 additional part-time programmers, and they wrote a lot of the Terraform magic modules behind the scene that we just have to include when we're pushing things out, which is and nice.
we sort of glossed over that, but we basically have a plan to hopefully release as open source our Terraform modules that we've used to build all of this, so that we sort of standardize across the board, across all these applications, to just basically set a bunch of variables and then just let the Terraform modules do the rest. And one question was, Jane Marie asked, why didn't we use the Docker native logging to the Splunk hack? That's a good question.
We talked about that early on, and originally we didn't do that because our Splunk instance was running internally, and the only path to campus was from our core virtual private cloud, which is where we were just running core services, which Authman doesn't quite fit into. So we couldn't really do that.
And now with now that our Splunk is cloud hosted, we could potentially reevaluate that.
Could circle back and do that. Yeah,
so that's a good point. Yeah, this was a little.
Fargate does have the Splunk logging module in it. I thought so, at least.
Yeah, I believe so. But yeah, that's definitely a good question. But that's a little bit of a legacy decision there that was made at the time. That maybe you know, things change so fast, you can't always do that.
Before we go ahead here, did you want to, Matt from OSU had a question. Did you want to answer his question?
Oh, okay. Does the promotion
here, and then we'll save these others till the end.
Okay, yeah. Does the promotion of the image from QA to prod work? Is it a CI/CD state step or a manual thing? Yeah, it's definitely a manual thing. And one thing for now, yeah. Again, our process is I call it emerging, because our processes, and for that, frankly, for that matter, our organization is probably not mature enough to be able to have something this automated. I mean, everything down to our change control board is still a bit of a manual process. So as we evolve, this will so hopefully improve in the future. But one thing that we do have that sort of helps a little bit is that the staging and production container images are all staged in the same account ECR registry, ECR. So that makes it very easy. So basically, when we launch an instance and test, we're using actually the production registry and then test it out. And then if our tests are successful, then it's just a matter of triggering Fargate to bounce our containers in production to be able to consume that tested image that's already staged and ready to go.
All right, and one more quick thing that just came in was, I believe we just have one UI instance and one web service instance right now. Is that right?
At the moment, right. At the moment, we just have the one, and then yeah, as usage grows, we'll be looking to develop a way of dynamically expanding those, you know, as load demands.
This was sort of a soft rollout. We were actually teasing Eric because he rolled it out the day before leaving for a 2-day conference, I believe.
Yeah.
And so yeah,
and then yeah,
roll out a new service and leave. But it was a soft rollout, so it was only known to people who knew it was there. And
right.
interest is quickly growing. So
Yeah.
okay, cool. In addition to being the one who is interjecting Eric's presentation with questions, I'm actually here to present something meaningful too. So I'm going to get into that. I did jokingly put a slide in between the grouper and the Shibboleth slides that says what he said, because a lot of the infrastructure and the pieces that he is using for our grouper deployment, we're also going to be using for Shibboleth, specifically the logs, the parameter store, of course, the drone, CI/CD pipeline, and this is all going into Fargate. So for those of you who have been following through my presentations, I have been trying to get this out the door for quite a while now, and we jokingly had a race of who got things out first. Well, Eric won, but that means I win just being able to springboard off of his work. So I guess slow and steady wins the race. I'm going to talk about some of the Shibboleth specific pieces here, though, for getting the Shibboleth IDP Trusted Access Platform container into AWS. Starting with our current infrastructure, and this is probably similar to what many of you have today. We have IDP nodes running on campus on virtual machines. We have a couple here on campus. We have a couple in a remote data center. Those are all behind a global load balancer. We are using a database, but not for sessions. We're doing all of that on client side. The database is only for consent storage. So if you consent using our IDP consent delivery to releasing attributes to something, you don't have to do it per device. We're storing that in this MySQL cluster that is also distributed between the two data centers, globally load balanced, as is the authentication and the attribute store from Active Directory. Multi-site, globally load balanced. So that's all good, but we want to do better. So enter the Trusted Access Platform image. Our layering is going to be very similar to what Eric talked about. This is sort of an English version of what our Docker file is going to look like. There's going to be a couple things here that aren't in here yet. If you can't tell, I haven't actually written the Docker file yet. The things like removing the HTTPS pieces and adding in those certificates will still be here, but this is the basic gist of it. Oh, I guess I did put remove. Eric, did you put that in there? Remove HTTPS support. I don't know where that came from.
Yeah, we put that in there.
I didn't remember writing that bullet point. Okay, great. Hey, I was more prepared than I thought. So anyway, we're going to start with the Trusted Access Platform image. IDP, I'm sorry, you were asking about the session, meaning the user's session. We're doing client-side storage for the session. So I'll get to the magic in a little bit with the data sewer key, but right now we just have one on-prem instance that's generating new data sewer keys and pushing them out to all IDP nodes nightly using the script that comes packaged with the IDP. And so we don't have to worry about session storage across the GSLB since it's all client-side. So yeah, back to this image, you'll notice we are adding code to download and install the Giant OIDC extension. We do have the OIDC support for Shibboleth in production as of a few weeks ago. It's been working well, and we're going to keep that going in the image. We obviously need to import all of our configurations, our attribute releases and attribute resolver config. And obviously our branding, our UI, and all needs to be in there. We're also, and I'll get to why we're doing this in a little bit, downloading the Federation metadata and storing that in the container in the image at build time. So there are external dependencies, of course, with Shibboleth, just like there were for Grouper. One of those is our authentication, our Kerberos authentication to Active Directory. We're not using LDAP auth. Kerberos auth gives a little more security. However, we are using client-specific key tabs when we do the bind. And since we do have a cluster that's going to vary in size and in names dynamically, we have yet to figure out a way to work around this. So plan B will be to move back to LDAP auth if we don't figure this out in time. But this is a solution we were working on a while back. And as a matter of fact, we were reminded of it when we were working on these slides. So we'll be getting back to that shortly. We will be using Amazon RDS for the database for the consent storage in place of the MySQL cluster, so everything can be cloud-based. And eliminating the on-prem MySQL database. We will open up the RDS instance to those campus IPs connecting out, so that they can use the RDS instance as well for consent storage. That, yes, is a little weak, but unlike session storage, what's the worst thing that happens if you can't reach your consent storage? Somebody's annoyed and gets prompted to consent again. Not the end of the world. It doesn't keep you from getting to the service as long as you have your fail-fast configuration set up properly in the IDP. And the LDAP, the attribute store access, we do have that on-prem, I believe Eric mentioned that on-prem Active Directory domain controller running in AWS. The nodes running in AWS will talk to that. The on-prem nodes will continue to talk to our on-prem Active Directory. So everybody will have a local attribute store and authentication source to talk to. So here's some pretty pictures, because everyone knows I love pretty pictures. This is what things look like today. You see at the top, we have the global load balancer going to the local SLBs in each of the 2 data centers, which are doing health checks, smart health checks in front of the actual IDP nodes running on the virtual machines. Those IDP nodes are talking to that database. Also not appearing in this picture is Active Directory. So Richard, we're using Brocade GSLB, our networking folks manage that. So we pretty much just smile and nod and ask them for help when we need it, which is fine with me. So that's what things look like today. Here's what things are going to look like hopefully very soon. Eric, I'm going to let Eric answer that question.
Oh, sure. Yeah. On-prem AD, are you installing your own AD, DCs, and WS, or using AWS AD integration? No, yeah, we basically stretched our on-prem Active Directory with EC2 instances of domain controllers in AWS, one in 2 different availability zones, so that we have full cloud redundancy. So basically 2 domain controllers in AWS, and then we're doing the same thing with Azure as well. So basically we basically have a stretched domain across both cloud and on-prem.
Eric knows more about Active Directory than me, plus it gave me an opportunity to take a sip of my water. So thank you, Eric.
Sure.
All right, those are ones that we installed correctly. We didn't use AWS's integration of Active Directory.
Correct. Yeah, correct. There was some limitations with the AWS AD integrations. We're not necessarily taking them completely off the table, but for at least for the purposes and the business needs we had at the time, our own instances in a separate logical site were basically the best way to go. for us.
So here's the future picture. You'll see the GSLBs replaced with the application load balancer at the top from Amazon's Route 53. That's going on the one hand to the Fargate nodes. There's a few of those there, which are in turn talking to RDS. And also, again, not appearing in this picture is the Active Directory instance in AWS. On the other hand, the ALB, if the Fargate nodes are unavailable, will fail back to the on-prem SLB and the on-prem nodes, which will still point out to RDS if for consent data, but use the on-prem Active Directory, again, not in this picture. The beauty of this is once we are comfortable with the AWS setup, when we know things don't need to fail back to on-site, when everything's working happily and we've scaled up to a cluster size that we're happy with, we just tell the ALB to stop sending traffic to the on-prem SLB and we retire that infrastructure. So it's a nice, quiet, easy cutout and gives us a safety net in the meantime. So Eric, we got a question. Do you know how big our pipe is? I don't know that.
We have no pipe to AWS. We're actually using a VPN route by a commodity internet to between AWS and here. We don't have any dedicated path to that. So far so good. We are investigating the I forget the marketing thing for their direct route, but that we are looking into that, but we don't have that currently.
Probably starts with the word elastic.
Yeah.
And thank you, Internet, too, by the way, for giving us the path that we do have right now. Matt, we actually can't. Oh, for the on-prem containers you were asking about, or were you asking about the AWS containers?
Oh, share details about the AWS host spec sizes that you're using for your IDP containers.
Yeah, are we talking on-prem?
Oh, for AWS.
Oh, we don't have them yet. This is all vaporware right now, if that doesn't actually discredit my presentation at all.
We do have a test environment.
We have a test one out there, yes.
I think the container sizes are 4 gig right now. We just don't know whether that's too big or too little.
And that's without MDQ, so
yeah.
MDQ should help. No, that's okay, Matt. Don't worry about it. The MDQ is going to bring that down considerably, so I'm kind of glad I did procrastinate until MDQ came out for that, because it's going to bring the size down a little. We have some pretty, as many of you do from pre-MDQ days, some pretty beefy VMs running the IDP as they're consuming all that Incommon metadata and the EduGain stuff that comes along with it. So we will definitely benefit from that and hope to have some smaller containers and you know, just number rather than size in benefit. And Richard, EKS wasn't out yet when we started this. So we didn't even look at Kubernetes. Matter of fact, Fargate wasn't either. We started on Elastic Beanstalk, but we moved to Fargate is a much better way to go.
And I think if you have an existing Kubernetes infrastructure on premise, then that would be a very natural progression. But since we had nothing already, then Fargate was simple enough for us.
But now that EKS is out, and if you're used to EKS, Kubernetes, and that is a good way to go. I mentioned a while back, if you guys may remember, because I've gotten sidetracked a little bit, that we are pulling the metadata in at build time. You know, it's one thing if your IDP fails a metadata refresh and uses cached metadata once in a while. It doesn't turn out very pretty. And Dean, that was a very timely link. Thank you. It doesn't turn out very pretty if your IDP can't pull in the metadata on startup, especially if you don't have any metadata already on disk, which if you don't build it into your image, you don't. So we are pulling in the metadata to have something on disk so that if it fails on startup for some reason, because we're not only pulling from Incommon, but we're also pulling from our multi-campus federation, both obviously available from multiple redundant points, but still if that fails, we've got local metadata to fall back on. Yes, it might be a little stale, but it's better than nothing. And then hopefully the next refresh will bring us up to date. That was our safety net. Obviously, MDQ fixes that quite nicely. Because we can we can rely on that that cached we can just pull in the metadata as we need it from the per entity metadata service. So as a result, we if we fail once in a while, that's okay, but we're not going to be dead in the water. So that the MDQ was a nice addition to this, not just for the memory footprint that I mentioned a minute ago.
Vasilios is asking how many SP integrations are we currently supporting?
SP integrations,
I think
we
last time
have
we had like 80 something active, but I don't know how many we actually have registered.
Yeah, you've got some numbers from Splunk. I know we have several hundred on-campus SPs registered that aren't in Incommon, and then we probably have a few dozen that are in our local metadata file. I would really need to dig to see how many we're federating with from Incommon, because thanks to default attribute release and all that magic, I don't even have to know about that most of the time. So, but it is definitely in the hundreds. So one of the big snags we've hit here is this data sealer key that I mentioned before when I was talking about session storage on the client side. The problem there is, how do you get a new data sealer key to a varying number of IDP nodes running in AWS when none of them is really the master node and they're all running in containers? This hasn't been a simple challenge. We met with a few folks from Internet 2 and with Scott Cantor last year, and he has begun work to turn the or to support data sealer key retrieval as a scripted element, which is really nice, because anything that you can script that you can get to return that data sealer key object can be used. In the case of talking to AWS, in this case, Secret Manager, which is slightly different from Parameter Store, but very similar, that's just a web service call. So we can use a script to retrieve the current and maybe previous data sealer key from Secret Manager, and just let all that be as if we were reading it from disk in the IDP, and we could do that in all running IDP nodes dynamically. So let's see here. Where was I going with? Oh, so parameter store versus Secret Manager. I was just going to say Secret Manager is kind of like parameter store with extra bells and whistles. And in terms of bells and whistles, I'm talking about it can handle the key rotation. It can handle, with a Lambda function, the new secret generation. So that is that is going to allow us to just let the IDP consume stuff. Now, until that scripting is available, we have a couple of fallback plans. One is to have the IDP node be automatically rebuilt, including generating a new data sealer key, and redeployed with a rolling cluster restart on a daily basis. This keeps the data sealer key fresh, but at the same time, it gets it to all the IDP nodes at the same time, or close to the same time. There's going to be a little bit of latency during the cluster restart when that's going to be an issue, when things will be out of sync. Another option, which we've been trying to avoid, but it's our sort of plan C, is putting a cron job and that script to pull things down from Secret Manager in the container, and have that run at the same time on all the nodes on a daily basis. Scalability, I've been mentioning several times this whole concept of a varying number of nodes. We can do way better than having 2 large nodes running all the time. That is clunky and unnecessary amount of resources, especially if you're paying for those out in AWS land. We can have smaller instances that dynamically rescale. ECS allows that dynamic rescaling. So if it's 2 in the morning in the middle of the summer and no one's using it, we can just have this one lone IDP node running out there. If load picks up like at 9 a.m. on the first day of the semester when all the students are walking into class and logging into their devices, then we can dynamically scale whatever we need to support that load. And then the ALB obviously will front all those connections no matter how many we have running. We can distribute them across regions for redundancy as well. So before we get to questions, we've got an extra treat for everyone. Bonus content, but wait, there's more. We wanted to introduce you all to Shibboleth in a box, or Shib in a box as we call it here, because it rolls off the tongue nicely. Shib in a box is our goal here at Illinois to build a better SP Dockerized image. I feel like I'm doing an infomercial here. It slices, it dices, and boy, oh boy, does it catch those fish. We are building Shibboleth as a microservice. It eliminates the need to put the SP and Apache in every one of your images, which is especially annoying if you're just putting Apache in there just to front something like Tomcat or some other application server as a proxy, where you could have, in this case, the ALB talking directly to Tomcat or that service. Horizontal scaling, you've got a busy application, it's got lots of nodes, but the authentication isn't amounting to a lot of that traffic. Well, that's fine. You just need maybe one Shib in a box node in front of all those application nodes. Or maybe your authentication traffic starts to pick up, so you can deploy a second Shib in a box node as well. This reduces, obviously, the container size, since you're not putting Apache and Shib in all those images, and it lowers your cost. So what's in the box? Obviously, ShibSP and Apache, and a lightweight API that everything else uses to talk to it. For those of you who have done much out in Amazon land, yes, this means you can have serverless pieces that can speak to that API that can handle the talking to your Shib in a box component without having an actual server sitting around. Very similar to Cognito's SAML support, but a heck of a lot cheaper because you don't need to pay for Cognito SAML support, of course. This API supports full login and full logout. I mentioned earlier being able to deploy multiple Shib in a box microservices. If you have a busy service, they support the new Shibboleth 3.x session recovery function. So if you hit one Shib in a box container and then you later hit another Shib in a box container in that same environment, it says, I don't know this session. Oh, but hey, there's a recovery cookie in the browser. I'll grab that and decrypt it, and hey, I'll reconstruct the session. So it makes for SP clustering in that regard if you hit the other one, or if, for instance, one goes down because maybe you're pushing out new SP images while someone has an active session. The secret rotation uses very similar concept with Secret Manager to what I was talking about earlier with the IDP. We have all that logic already worked out. Good question, Eric. They all share one entity ID. This is meant to be one Shib in a box environment per application. So if you had a cluster of application nodes, they would all have the same entity ID anyway. Yes, you could put multiple applications behind the same Shib in a box environment, but you probably wouldn't want to. So yeah, this is meant to be the same thing as if you did have a cluster of containers. So I mentioned this is all being built here at Illinois, and it's going to be available as open source in the near future. We actually are hoping to contribute it back to Incommon to be part of the Trusted Access platform. Couple of little things here. Here are some links with resources that we talked about in our slides today. And we have a few minutes left, and we'll take questions. I think there's a couple back in the chat that I might have missed. Eric, do we want to hit those?
There's one back before. Charles asked what our monthly or annual cost of running all this infrastructure is.
We haven't actually broken this down by our per app basis quite yet, but I can say that even for the whole central IT, we're still only in the maybe several thousand a month category for all of our AWS resources. So that's been pretty good so far.
I will offer advice too for folks who are just embarking on this. We've been good about doing good tagging of our containers, our images as we're pushing them out there, so that once we do get to per service costing, we'll be able to use the tagging of those images out there to identify what's associated with what. So that's good advice for any of you just getting started with us.
Yeah, and maybe to further that, the the development of the process ahead of time, which is was creating us kind of our longest learning curve, was probably the best, because it at least avoids opening it up wide open for everybody willy-nilly, just starting creating Amazon resources all over the place, and then not really having any real control over that as well. So that process sort of helps the tagging and the life cycle of everything to make sure everything gets cleaned up properly. And that said, we do have a sandbox account that is always a mess, and we have to dump it out every month. People are running things crazily. But Richard asked also, do we have a private network endpoints on campus that cannot reach the cloud instances? And I don't believe that's the case. We basically used RFC 1918 space, private IP space on campus that's allocated for our Amazon resources, and everything is routable through the VPN between Amazon and campus. And I believe we even have recently routed private routes through to the other campuses, which have its own private IP space, non-overlapping private IP space with our campus, so that they could also share cloud resources for a few cases where we have apps that are multi-campus. Are your subject sources for Grouper also running in AWS, or are there connections back to your on-prem infrastructure as well? I think I mentioned, so we're using Active Directory, and the Active Directory has nodes in AWS, so that's our subject source, is technically in AWS for that purpose. What else did we miss here? Oh, PeopleSoft, not part of your IDM? No. We have we're a Banner shop, and Banner is operated by our administrative computing arm, which is actually a system level IT group that covers all the campuses, not just ours. But we do work with them closely for integration pieces.
Eric has some really cool things planned in the future for Banner and Grouper integration, which there's been a lot of that work within Incommon and the Trusted Access platform. One of our goals is to pull class roster groups directly into Grouper. I know there's been some threads on some Incommon lists about that recently. Right now we have a process that goes through several hoops to pull in class roster groups into our Active Directory, and we're going to make that much cleaner with that Banner integration. But yeah, that's sort of just a logical tangent I wanted to mention.
I think we're caught up on the chat questions.
Any other questions? Give folks a minute to, are we happy with MDQ? You know, I wish you hadn't asked that, Richard, because as a member of the Incommon Technical Advisory Committee, I'm ashamed to admit that we have only deployed MDQ to our test IDP. So yeah, we're happy with it there. I'm actually planning in the next week or so to go ahead and turn it on production. So I guess in that regard, we haven't noticed any problems with it in test. And so we're happy with it. And I suspect we will be happy with it in production. I've heard nothing but, yeah, there's a plug from Jane Marie. Thank you, Jane Marie, fellow TAC member and chair. Yeah, we've heard nothing but good things about it from the community so far. Anything else?
And just to chime on that from the Incommon perspective, we've heard particularly from a couple of SPs that are very happy with how much it's cut down on the time it takes to download the aggregate versus just going out and getting what they need.
Lynn, the MFA product around here is the bee's knees. I like that. Our MFA solution is Duo. We've already seen it working fine from the AWS deployed test instance of the IDP. So yeah, we're not expecting anything to be different with that from the Fargate angle. And Matt, the bridge between the applications and the SP is a lightweight API that our developers have written. I was nervous at first because they were sort of exposing security there, but they showed me their security model. They ran it past our security folks. It's pretty tight. Plus, it's all protected within all protected within that particular Eric, what's the terminology? Not task, but well, I guess it is within that task, isn't it?
Yeah, it'd be a task. Yeah.
So yeah, you're pretty closed off from the world. Sizing, I don't know. It's not that big. It's not that big. And let's see, what was the other question Eric asked? Sizing
And compute expectations. Oh, was it Fargate also?
Yes, yeah, it's actually it's intended to run in Fargate as a microservice. Yes, I mean it's really just a container, so you could get creative and do other things with it with a little extra work. But yes, it's intended to run in Fargate. So, I think we're one final question. Going once, going twice. Yeah, the sizing question is less relevant. That's correct. So. Anyway, that's the news here at Illinois, where the apps are strong, the services are good looking, and the students are all above average. Back to you, Dean.
I don't even know how I follow that. Thank you, Keith. And thank you, Eric. Great presentations, as Kevin Maroney said. It's very dense, but very digestible, and even he could follow it. So there you go. Just a couple of things that are coming up. The technology exchange is a little bit later this year. You can see it's December 9th through 13th. In New Orleans, we'll have 2 days of 2 tracks, just as we have in the past, of campus case studies, track sessions, and sessions on key identity management issues. And then the ever popular advanced camp will be on the last 2 days, and that's where it's an unconference. We do the scheduling on site when we're there, and people vote on what they want to attend, and away we go. So if you have a chance, that's a good thing. Actually, that's where this presentation came from, because these guys presented it last year at TechX. And if you could move on, Eric. We also have several training sessions coming up this fall. There's the URL you can see, and it covers all of the software that's now in the Incommon Trusted Access platform. And on the last slide, Eric, is a link to our evaluation form. And if you have a couple of minutes, it doesn't take very long, and we appreciate your feedback. And also, if you have ideas for future IAM Onlines, that would be a good place to, and that's not clickable. I'll put that in the chat. But anyway, that'd be a good place to suggest those. So thanks again to Keith and Eric for the great presentation. Thanks to everybody for joining us today, and have a good afternoon. Yes, slides from today, Charles. Yeah, they are on the, if you go to incommon.org, click on Academy, click on Webinars, and the slides are there. Thanks, Eric.